So, before we start, go check out Carnivore Land. It's now available on Steam, and of course you can find a link in the description below. Now, today we will actually see how to make a fighting system similar to what you see in Assassin's Creed and the Batman games, where we have an enemy that's going to attack us, and when he is trying to attack us, he can either attack us, okay, or we can counter his attack, and of course he will then be disabled. Now, of course, as you can imagine, the animations play a big role in a fighting system like this, and I actually forgot to create the logic if we are taking damage or not, but that's going to be pretty simple to make by yourself. It's just a raycast. Okay, and on the last part we will actually make a lot more enemies, and we will make them to have a circling behavior so that we do not get attacked every time from everybody. Okay, so it's going to be more manageable, and we will actually see how to make a ticket system for every enemy. Now, for this video we will not going to use these animations over here, since these are bought and you won't be able to follow along, but I've actually have made some other animations we are going to use. Okay, they are not the best you can find around, okay, and they're supposed to be from the first game I was actually making, and they have to do with swords, but you can freely use them in your own projects. Okay, and we have the movement and a few attacks and actually some executions over here. Now, in this video, or maybe this series, we will actually going to do it a little bit different from the others. So in this part we will see how to make the AI first, then our character, and then on the final part we will see how to create the brain behind it, that is the whole ticket system for the enemies. Now, of course, you will need a character of an enemy, and as always you will have the model behind it under the enemy game object, and I've also added a counter attack indicator, which is just a red box that we enable and disable when we can counter attack his attacks. Okay, now the animator, a rigid body, okay, angular drag something way up, we need drag, freeze rotation on the X and the Z, a capsule collider, nav mesh agent, even though don't mind a lot the values over here, since we change them from the script, and of course the script we are going to write. Now, before we write the script though, we need to set up the animator. Both the player and the enemy share the same animator, so that it's the same. So this is our animator, this is the parameters we are going to use. As always, forward, sideways, turn. Now, even though we do not actually use turn anywhere over here, I will tell you what you can use this for. If we are currently attacking, the attack type, so we know which of these three attacks we are attacking, and left hand AK, I don't actually use it anywhere, so there's no point. Base layer, we only have one, and then let's go see our first combat, our locomotion, our first layer, our first blend tree actually. Okay, this is pretty much a standard combat blend tree. Okay, when forward is at 1, he plays an animation that he's moved forward. When forward is -1, it will be him walking backwards. Okay, sideways, when he's at 1, he will move to the right, -1, he will move to the other position. Now, of course, you will might find some directions that they will not work too good with each other. So like if the two positions are both at 1 and at -1, you will need another animation that it's him walking, you know, diagonally, and that you will have to create some other animations or find something else to work with. Okay, so this is basically the animations the locomotion animation we're going to use. Now if we want to attack, we have a boolean. Keep in mind that this is a boolean which is currently attacking, and the attack type equals to 2, so it will play the attack animation of 2, okay, of 1, of 3, and these all attack animations have the same transition, pretty much, just the attack type changes. Okay, now on transition back to our locomotion state is pretty much the same, nothing. Okay, has X time and nothing more. And then, however, this all of these three states have a behavior attack, a state behavior inside them, which is disable attack, and this is a simple script, okay, which you add by clicking add behavior and new script, and you create the script, and then on simply the only thing we need them to do is on state exit is take the currently attacking boolean and turn it to false. Now this is pretty similar to what you see on triggers, but a trigger will turn to false the exact moment when this animation starts to play. But we do not want this. We want our boolean of currently attacking to turn false the moment this animation stops playing. Okay, and for instance in script a trigger will have the exact same line over here. We'll have it on here on state ender. Okay, so when it enters the state it closes the boolean. So triggers are basically booleans. Now the other thing that it has over here is for the second part of our video, so do not worry about this one exactly. And the way I've did it over here is just a different way of seeing how to close a boolean. Okay, so if you don't want to use a boolean inside the animator, so you don't want to add another boolean inside your animator, then you can simply get the script you want to use it and have the boolean over there. Okay, now so this basically the animations, the animator, the attack animations, our locomotion, and we have our executions over here. As you see from this side are the executions for the player and for the one that is going to die. Okay, and which is basically the animations for him. Now there's not exactly anything else to different or that you have to do. You see they do not have any transition, any parameters for the transition, because we will override them. We will override any animations we are playing with from the script. Okay, now the only thing that you want to add is this, the state behavior or disable attack, since this we will take them as attack, and later on the ticket system we will know if we are attacking, then the enemies will not attack us. Okay, so 3 animations and 3 animations for where they're dying. Now for the animations that where the character dies, you see that there is no transition, since on the last stage he just dies, so we do not want him to move anywhere else. And the next thing we can add is on the state the state behavior, which is of the state behavior of kill character, where it simply changes a bool inside the enemy AI script and informs him that he is dead. Okay, simple enough. The only thing you need to keep in mind over here is, of course, to be organized, and we will actually use the names of the states, not the names of the animations, even though most of the times it will be the same. Okay, so the name of the state animations of the states, we will use them to crossfade between the current animation we are playing and the animation and the execution animations. Okay, simple stuff. Let's go into scripting. Now, of course, the execution part will be on the second video, where we will going to do the player movement. Okay, and I had to split this up because there are a lot of scripts, and it might get too complicated for some. So open up a script and call it enemy AI. Okay, some stuff that I have commented out, don't bother yourself with this unless I say so. This is for the next videos. Okay, so let's start. We need a boolean, a public boolean, that if the character is dead or alive. Okay, we need floats. Those are serialized fields so that we can tweak them from the inspector. Dead zone and turn speed, how fast he will turn to look at the speed, to look at the target. Nav mesh agent, of course, the agent, the animator, public transform where is target enemy, public transform where is target destination. Now this is public because we might want to, on the ticket system, we might want to set him to not have the enemy as a target. We might want to send him onto a different destination because, you know, it's not his time to attack yet. So this is pretty much the same. I don't remember, maybe one of these is obsolete. We will see in a bit. A vector 3 look position where we want him to look towards. Okay, public bool if we are going to attack the enemy. The distance threshold is how close you need to be on the enemy, both to stop and to start the attacking logic. Okay, so attack timer, how fast you're going to attack, if your attack is interrupted, and the public game object is the counter attack indicator, which is the red cube over here, where we simply enable and disable when the player can counter attack. We start by setting up all our references. Okay, setup animator, you have seen it in all these videos, which is this. Okay, so we set up the settings for the agent from over here. So we do not want the agent to update the rotation, since we always want to look at the same position. Okay, the speed of the agent, 1 works pretty well from what I've seen. The stopping distance, we want to be the distance threshold when we are going to start the logic for us to attack, minus 0.5, so that it's not exactly on the edge. Okay, so that you do not have problems, you know, so that it's clear that he's inside the attack logic, that he can start his attack see his attacking logic. Otherwise, there might be, might be a balance. He might stop and run again. So it's better to be clear when we start our logic. So the dead zone, we actually need to turn it into from degrees to radians. Okay, a target destination position is the transform dot position, starts as the transform dot position, and then we turn the counter attack indicator to false. Now, if we are not dead, then we start our logic. Now, of course, this fighting system is, we just take it that we start from combat, okay? Waypoints, AI, and all this stuff you see in stealth games or other stuff, those are for another video. Some we have already done. So, we are not dead, and we are on combat. What we need to do, we need to find the destination. We need to look at our target, of course, and then we need to find to move towards there. We need to play the animations that makes us walk over there, and then state switch is if we are attacking or if we are not. So let's see them with the order. I have it over here, so I'll close this so I do not forget anything. So find destination. We need to find the distance from the target. Okay, vector3 dot distance, transform dot position, and a target destination position. We need to send our agent towards that destination, and then if our distance from target is lower than the distance threshold, then the attack timer, we add into our attack timer. That means we have reached our enemy and we are in close range, so that we are able to attack. Okay, we add into our attack timer so that we do not attack instantly. Now, I've counted in games in Assassin's Creed or Batman, and it was about 2 seconds before both in Assassin's Creed and Batman, it was 2 seconds before the counter attack indicator was enabled. Okay, and 2 seconds after, you were actually, if you didn't counter attack, you were attacked. Now, from the moment you reach the target, you have 4 seconds, otherwise you are going to be attacked. Okay, so after 2 seconds before after the enemy has reached us, then we have 2 seconds to counter attack. Now, since this is going to be on the next part, you can write it and simply comment it out. Okay, which is simply calls another function we have on a character movement, which is the player movement, which says enable the counter attack. Okay, so we enable the counter attack indicator so that the player knows that he can counter attack, and if the attack timer is higher than 4, then that means the player couldn't counter attack, and then he actually takes damage, or the enemy attacks. So we disable the counter attack with the same function. We just simply pass a boolean. Okay, we disable the counter attack indicator since you cannot counter attack anymore, and we set the boolean of currently attacking to true and the attack timer to 0, so that it resets once again. Now, if we're not near our target, then the counter attack indicator is false. and this is the find destination. Look at the target. Now, the look at the target position is the look position is the target enemy dot position, of course. We find the direction where we want to look. We zero the Y as always, and then we create a new rotation with the look rotation, and we pass the direction we want to look, and then we simply pass transform.rotation equals quaternion dot spherical lerp transform.rotation. We pass the new rotation, and all this by time.delta time multiplied by 10 speed. Now, in case you want to pass values to the animator, where you have on your idle state, instead of simply an idle state, you can actually have a new blend tree inside over here. Okay, well, it can be a directional blend tree. Okay, where you have on the 0 on this threshold, with this will be on 10, and on this threshold you will have the, let me see it, you will have the idle on 0, the 1 and -1. Okay, but if you want him to turn to the left or to the right, but his position will be stationary, so kind of like pivot turn, not strafe. Okay, pivot. Now let me delete this since we do not have these animations. And then, okay, then you can use the position of the enemy, and you can turn it from wall position into a relative into relative position. So it's actually we take it from the wall space and we turn it into a local space, so kind of like having a child game object of our enemy. Okay, and then from the relative position, if we take the normalized, you do not have to use the normalized, but you can normalize it. If you take the x, it's how much to the sides or to the left or to the right your target is looking. Okay, it's pretty simple. I hope it is. Now, navigation AI. Okay, first we need to find an angle, and this angle is, we find it by a find angle. This is a new function where we pass a transform.forward the desired velocity of our agent, and we pass the up vector. Now, this find angle is straight from the stealth, from the official stealth project. Okay, and you can read what it actually does. Okay, and this will return basically the angle from one vector to another vector. Okay, and then if the absolute value of our angle is lower than the dead zone, then it turns our transform to look towards the transform dot position, which is our own position, plus the agent dot desired velocity, and of course we set the angle. Now we do this because if you reach a target, it might start looking into different direction, or might have a different offset. Okay, thus this simply hard codes when you reach your destination to stop there and move nothing and do nothing else as far as the navigation is concerned. Okay, now we have the navigation AI. The only thing left is to handle the movement animation. Now, this takes our desired velocity. So we have our desired velocity from the agent, which is we know where our character wants to move. Okay, towards where the character wants to move, but we cannot pass that to the animator since it's on wall position. So to be at a value that we can actually use, we need to convert the desired velocity on local coordinates, and it's a simple way to do it actually. We just create a new vector3. I've just given it a clear name so that we know what it does. Desired velocity on local coordinates. Okay, we call transform the function that says on inverse transform direction, which simply changes direction from wall position to local position, and we pass the desired velocity of the agent, and that simply gives us where we need to move but on local coordinates. So for instance, let's say this is our target. Okay, we want him to move over here, and let's create, I actually have a destination target. Now the direction from the direction on wall position is the destination target dot, okay, the destination target position minus the enemy's transform dot position. So it's actually x minus 0, y minus 0, and not this, y minus 0, and z 10 minus 9. Okay, so this will return 7 on the x, y on the 0 as it is, and this will be around 1.05. Now this is a direction or wall position. If it was on local position, and so if I take the destination target and drop it and make it a child of my game object, you will see that it actually changes the whole coordinates of his whole position, his whole where he needs to move. Okay, so if you basically normalize that, you have values you can use to your animator. Okay, so that was pretty much it. You change the wall position into desired on the local coordinates, and then you pass on the forward, you pass how far on the z is our destination, and on the sideways we pass the x from the local coordinates, and of course you can apply it with dump time by time.delta time. Okay, now this is basically it for today. We will do on the next video, we will see how to use the actual, how to move around player. Okay, and he has a lot of stuff, as you can see over here. These are a lot of stuff, and pretty much need a whole video for this. Now let's see how our enemy AI will work. So for instance, if we disable the look at the target and go into our script and take our destination target and drop it as the target enemy, and let's unmaximize that. We hit play. Now if we do not get any errors, and we do not, you will see that instead of turning to look at the destination target, he's actually, and of course we get an error over here, and let's see why. And yeah, because we get, let's comment this out and let's see it once again. Okay, he's actually, instead of turning towards that position, he's actually strafing the way he does. Now of course he is attacking to nowhere, but if we keep moving, you will see that he will never turn to look at the target, but he will actually try to work with the blend tree we have created and play the animations we want him to play. Now of course you remember that we're moving diagonally, we have the problems. Now in Assassin's Creed, they actually do not, the way he is looking, they actually mirror the animation when he's at this position. And if you play it at least on 3, I think on Assassin's Creed 3 they did that. Okay, so whenever he had to move diagonally, where there is no, the placement of the feet are a little bit tricky, then they mirror the animations, the whole blend tree, so that he can move towards the, so that he can move without the animation looking pretty boring. Okay, so now of course this is this technique over here is pretty useful on other animation, on other types of systems, and it's actually pretty useful and pretty easy to understand. So let's see it once again, and let's see what we will do on the next video. Let's give him a target of our player, and let's try to fight. So on the next video we will actually see how to move our player the same way we move our enemy now, but without the AI, but how to pass the values to the animator. And when we are to counter attack, we actually counter attack, and how we can attack. So that was it for today. Don't forget to like and subscribe. Don't forget also to go check out Canyon Volant. It's now available on Steam. You can support me and help me make more videos by pledging on patreon.com, where with $5 or more you can get access to a Google folder where I have all the scripts from the videos, and I've also available the videos a few days earlier before they go public on my channel, and in turn you also help me make more videos. So thanks for watching, and I'll see you next time.